Hello. In this video, we are going to discuss the effect of monosubstitution by a halogen for further electrophilic aromatic substitution of substituted benzenes. Halogen atoms have a paradoxical effect on further electrophilic aromatic substitution in that they deactivate the ring relative to unsubstituted benzene, but they ortho para direct. The first halogen atom that we are going to consider is fluorine, the most electronegative of all the elements. We would imagine, and we'd be correct, that of all the halogens, fluorine has the greatest deactivating effect. If we compare it to other deactivating groups like nitrate, the effect isn't nearly as pronounced. Please see the following structures of computed products and intermediates for the addition, electrophilic aromatic substitution of methyl for hydrogen at the ortho, meta, and then para positions. The second of the halogens that we're going to consider is chlorine, which is the third most electronegative of the elements, and it has the element that has the greatest electron affinity. Like the other halogens, it deactivates the ring relative to benzene, but directs ortho and para. Please see the following computed structures for the chlorobenzene and for the intermediates for the electrophilic aromatic substitution of the methyl carbocation at the ortho, meta, and para positions. Next, we consider bromobenzene. Bromine, being a halogen, deactivates the ring relative to benzene, but not nearly as pronounced of an effect as fluorine, and it directs ortho and para. Please see the following figures for the structures of bromobenzene and for the intermediates in the electrophilic aromatic substitution of methyl carbocation at the ortho, meta, and para positions. Our fourth and final halogenated benzene is iodobenzene. Iodine being the least electronegative of the halogens, we would predict to have the smallest effect. But being a halogen, it deactivates the ring slightly relative to benzene, yet it directs ortho and para. Please see the following computed structures for iodobenzene and for the Meisenheiser complex intermediates of the electrophilic aromatic substitution of methyl carbocation at the ortho, meta, and para positions. please see again two tables showing the computed energies of activation for the intermediates in the electrophilic aromatic substitution of the methyl carbocation on the various halobenzenes. Again, in summary, any number that is larger than 0, a positive number, means it's less reactive than benzene. Any number that is smaller than 0 means it is more reactive than benzene. The smaller the number in magnitude, the more negative the number, the more favored the reaction is. So you'll notice in general that the values for the ortho and para positions will be smaller, will be more negative than for the meta positions, thereby confirming that the halogens are ortho-para directors. I thank you again very much for your kind attention. I hope you will like and subscribe. And as always, have a good one.